Thank you very much for introduction, and thank you much for invitation to joining you. And I was happy to come here. Actually, my probably first visit on scientific or work-wise for 20 years. So happy to join the Lithuanian audience and try to share some of my experience and understanding of the business we're talking about. Presentation is itself, the name is from idea to construction and operation. I'll try to guide you through the process a little bit of the. From my part, it's infrastructure projects, infrastructure business, and try to highlight some of the things we do, some things we could do better, and maybe some of the problems which are arising from those processes. Short introduction of myself, my background. I'm actually probably as one of not many of here, actually not an engineer. I started my career as a geologist and done my studies first in Vilnius University, just across the river. And then I moved to Sweden, continuing with the PhD studies, and finally worked for the Swedish Geological Survey as a geologist for some time. And then after 2007, shifted a little bit from the geology to the engineering geology and came into also the rock and tunneling engineering processes. So worked for a number of Swedish companies, Berga, smaller local company, and then international companies, Pöyry and AFRY later on. And then since a little bit more than a year ago, started my own consultancy company and working basically on the engineering geology tasks and rock and tunnel engineering, and as well we'll show a little bit about the ROV inspections or ROV maintenance tool for the underwater or submarine structures and constructions. When we got the first invitation from Simonas about joining the meeting and talking about contact, got a little bit like kind of a wake-up call. What exactly is it for myself, and how do we or myself understand it and try to use it in our daily work? In infrastructure, we talk a lot about the digitalization, active design, beam 3, beam 4, whatever kind of combinations of the structure. But I think come to my conclusion that it's basically, it should be described maybe as a process, and the process which we should imply and should use from the basically initial idea, through the design, through the construction, and not to forget also the operation and renovation of our objects. And of course, contact comes with that one, that also we need to use integrated digital tools in our work from beginning to the end and through the entire process, and also taking into account also the LCC, the life cycle cost analysis, and as more and more important, becoming also the environmental sustainability factor in our designs. So it's not something we just put on our slides, environmental assessment, and we all fight for the nature. We actually have to include in our designs and find solutions, materials, and type of works to be able to fulfill those obligations. Most of the things I will talk about the infrastructure project and specifically on the tunnel engineering. So if you come, maybe not many of you working with the tunnels, but I hope you can find something similar to whatever area you are working with and on your own problematics in that matter. So I will start actually with the lifeline of the infrastructure project. And it's maybe somehow more complex and longer compared to the construction of the housing or construction of the buildings. But it basically goes through the general stages from localization. We're doing some basic design. We're working with the detailed design, then going to the construction period with the constructions. And then, of course, after construction is finished, we're having the life expectancy for some projects for the operation and maintenance period, which is also an important part of the lifetime of the object, and coming to the end to some either decommissioning in the end of the lifetime or some major rehabilitation, renovation work, basically to extend the life of that part. And I think important thing in that matter is also how does the legal part of the project is built, and what kind of contracts we implementing or using for achieving all the tasks in the different stages of the lifetime. If you're looking at the first three ones, from localization, basic design, detailed design, mainly there's two players, maybe the client. In infrastructure projects, it's usually road administration or traffic administration kind of public client, and the engineering and designing company, which going forward, producing documents, designing, answering the tasks, and goes for that period until the detailed design is finished, and then goes into the construction period where the contractor is involved. When we're looking at the design contracts, normally, or in some cases, it's a continuous process from localization to detailed design. In any cases, it can be split in pieces and bits. And maybe there's one engineering company doing the localization study, the other one gets a contract for basic design, and then the third one is a detailed design. It's not the advanced case and not best case, but it happens. And those contracts either is fixed price contracts or unit-based contracts. In engineering terms, usually hourly costs or hourly rates-based contracts. Both of them have probably advantages and disadvantages. Don't go into the details, so maybe we'll come back to that later in the discussion. But then we come to the construction period. Construction contracts also have a different setups and a different type of involvement of the contractor. Normal construction contracts, basically, maybe most of the people used to, is like unit-based contracts, where the contractor prices the cubic meter of soil, cubic meter of concrete, some ton of steel, and based on that one, erects the structure based on the drawings or models produced by the client. There's also another kind of variation of that, design and build contracts, coming quite often and becoming more and more popular, basically where the contractor, together with their own designer, comes at the detailed design stage, and basically are very much involved in the design period, the final design period, and the construction period. So basically have a continuation from the design stage to construction stage. And the third one, which is been used and successfully used, is yearly contract involvement. That's meaning that client have possibility to choose the contractor early in the project, usually sometime during the basic design phase, and having the contractor involved in the project, the designing, the lifeline of design is basically don't stop at the detailed design stage. It actually looks forward into the construction period and beyond construction period. So having like continuation of the designing solutions based on that stage, which expands quite a larger project. And in some cases, this early contract involvement even involving a contractor into the operation and maintenance of the facility for some 5 or 10 years or whatever kind of time of period. So basically, you expanding the boundaries of the one involved party in the contract from being a single input at one stage, being the part of the full process of the execution. If you compare that to those design stages or the contract, the process stages into the degree of sort of digitalization, maybe you can call it, or complexity, we start in the localization study with a kind of basically the existing data. And during those periods, preferably, ideally, we should build up the complexity, the digital status, the digital complexity of the project we're doing, due to all the stages, not stopping at some stage, but continuing from the design to construction to maintenance, and keeping that in mind for the entire period of lifetime of the project. However, reality often looks more like this, that we have splits into the continuous process of the project into the stages due to maybe the legal issues of the contract, due to the different players involved in the contract or in the process. And many cases, we basically redo a lot of work between the stages. So if we have one company doing the localization study, it maybe delivers just the drawings. And at the basic design stage, the next company have to start from the scratch, basically build up the model again. So I think we're losing a lot of the knowledge, a lot of money and time, which we spend during the early stages by not fully integrating the existing data into the next stage of the project, and next stage during this operation. And if you're looking at the time scale in the bottom of the graph, time schedule is also becoming an important issue. Design phase, depending on the complexity, maybe takes 3-10 years, give or take. Construction period also maybe about the same period. But then we have, if we're talking about infrastructure projects, roads, railroads, bridges, whatever, lifetime of that subject is basically hundreds of years, maybe more than 100 years. So having not utilizing or forgetting about the operation and the maintenance period of the facility is kind of forgetting the largest portion of the lifetime of the object we're building. And unfortunately, that's what's happening, is that when you're getting to the stage of the construction and into the maintenance and the operation, that's, I think, the biggest gap of where we're losing a lot of information. And I think the previous speakers just before lunch touched about a little bit that one. What are we building models for? Are we building them just to answer the engineering questions? Are we building them for answering the engineering and completions and construction models? Or are we building that for the lifetime of the object? So it has to be kept in mind, but I think not losing the data and keeping that for the entire process of the lifetime of the object is basically an economical investment, that we don't lose the data for the future years to come. Short example on how does it operates in the reality. When we're starting with the localization study, we're starting basically with some sort of political decision or economical decision. We need a road. We need a road which maybe starts there and then ends up some other connecting two roads. And we're getting this spaghetti-looking plate of the options, and from economical, political, social, technical points of view, trying to find the best optimal way for the localizing, in this case, a road. So during the result of a localization study is that we came up with the most optimal line from all those kind of points of view, and define where we want to build the road, what kind of supporting structures we needed, how this will be connected to the existing network, and so on. And then we go to the basic design phase based on that one. So there's a complexity of the digitalization, let's say, increases drastically, because previously you basically evaluate a lot of soft parameters, and then you're getting back down to the more or less technical issues. So normally what we do is a corridor kind of design, where we define what kind of road you want, how wide should be, how many lanes should be, what kind of in the middle between the lanes should be, how shall we form the ditches around, how we form the slopes. In case of tunnels, how big tunnels we want. Is it 1 lane, 2 lane, 3 lanes? Do we need any technical spaces and so on? So basically we're getting these typical sections. And normally, semi-automatically, automatical way, we can generate basically the layout of the entire structure we want. So we're getting the vertical, horizontal profiles into 3D, but generating those enough detail design to be able to go to the public evaluation process, local counties, normal public, any officials which has to kind of evaluate the project. We, based on that one, can start to work with environmental impact assessment plans, and even quite important and restricting factor, the land acquisition process. So when we're getting to the stage of the basic design, we may be interested in scale of meters, but then we go down or centimeters, we go down to the detailed design and have to solve all the small details in the process. So when it comes to tunnels, do a lot of geotechnical investigation. We build our 3D models with the existing known structures or known weakness zones or known variation in lithology or ground conditions. And based on that, kind of define what kind of technical issues we have to solve from the stability point of view. The other thing which is important, and we come to the detailed design, is also for the tunnels, which is kind of enclosed spaces. So we need to get a lot of cooperation or collaboration between the different technical areas to get enough space for drainage, for electrical systems, for ventilations, for structures in this combined tunnel space. So it's a lot of coordination work, but even though in the technical point of view or designing point of view, a lot of that one is basically semi-automatical processes. We having kind of defined straight reference line, and we adjust all our objects to that line, and all technical areas can collaborate in that way in this closed space. So when we finish with our detailed design, we prepare the tendering documents, and normally it's long list of paper documents describing requirements, what we want to be built, and how it has to be built in some way, and what kind of requirements have to be fulfilled by the contractor. And we prepare the bill of quantities. We prepare 2 or 3D models as an illustration or as a contract documents, and prepare by tradition or by the use as we used to do before, also even some drawings. And some drawings is just for illustration, but in some cases, depending on the degree of beam modeling you do, maybe also kind of address this time aspect for the construction period. So contractor getting all these documents and then goes to the production site and start building our tunnels. They follow kind of the circle, drilling, blasting, reinforcing, and going again. So in the end, we end up with a tunnel which is kind of reinforced tunnel, structurally stable tunnel, goes to the stage where we're installing some water protection systems, usually shotcreting them for stability reasons, and then in the end, basically building the road in the bottom of the tunnel as like any other road construction you used to see. What's happening after construction period? Basically, then constructor finishes the construction works. It has to develop, update, and generate the as-built documentation. And unfortunately, from my perspective, and unfortunately from maybe our clients, in Sweden at least, the as-built documentation is still done in 2D drawings, which are delivered at the end of the project. One of the reasons for that one is that traffic administration is using a management system called Batman, Bridge and Tunnel Management System. And limitation is that management system can't accept the 3D models. So that's a technical issue. It's continuously updating, and hopefully in the nearest future it will be possible. But as of today, the as-built documentation, which then goes to the maintenance phase, is basically based on the 2D drawings, and basically can understand that if you're going to do any renovation, inspection, improvement in your tunnels later on, then you basically have to go in your digital stage, go down to 2D drawings and start from there. So back to the same figure we looked at previously, is that these ups and downs in the process of the digitalization and model-based design work has to have a target that we try to avoid as possible those downs and keep the stream process through the process. And don't forget that after we constructed the bridge or tunnel or road, it's just the beginning of its life, and it still have decades ahead, and it still need to have a maintenance and operation during that time, which preferably is also done with the help of the digital tools. So to summary, or a little bit of the maybe takeovers to the discussions later on at the tables after the meeting, what do we need to succeed with the contact and this digitalization in our engineering works? I think the important thing, it requires a long-time engagement from all the parties, both us as engineers or engineering companies, the contractors, and nonetheless the clients. And I guess basically maybe the clients in that sense are important players to keep this ball rolling during the entire process of life, because they are the only ones who are from the beginning to the end of that we're working. So it's hard to have it to succeed if you're running it as a one type kind of test project or one specific project, one specific facility. It requires long time. It's a long time competition, a long time run, and requires that kind of engagement. We also have to think and analyze maybe what kind of contract we're signing, and from the client's part, that kind of promote the innovation in the contracts, that not only fix on the pricing or the fulfilling the requirements, but also price those ones which comes with the innovation. We're probably not able to solve everything at once. We have to have a kind of realistic ambition level, what level we want to achieve, and it has to be achievable. If we set level too high, it will be not possible to succeed. If we put it too low, then we don't make any progress. We're still doing our drawings as we did 20, 40 years ago. So realistic but ambitious level. We need, of course, also common formats for 3D models and built-in model intelligence. And I think previous speakers talked about a little bit about web-based systems that don't require specific software to be operated. And that's a challenge. Then you have a different software during different periods of time. And most important, maybe need also patience. It's probably not solvable around 1 day or 1 week or 1 year. It takes time. So patience and some sort of flexibility to be able to succeed. And then a couple of last slides. It's easy, I guess, to find the ways how we solve with the assignments or the projects we're designing and building today. But 90% of our infrastructure is 50, 60, 100 years old. And that one also has to be maintained and also has to be involved in our digital world and in our digital tools. And from the client point of view, it's hard to, or maybe impossible to have a parallel maintenance systems, one for the new objects and one for the old projects. So we have to kind of find the way, the middle way, where we can put the old structure, all the old structures and new structures in the same maintenance systems. So we have to find this middle way. And to be able to include those old ones, we need to create, basically digitalize whatever it's built since years ago, either from existing drawings or from the, as we see reality in the field today. And have one example basically of that kind of system. It's from the Stockholm's local train network system, digitalized database, web-based database, which basically is one of the oldest tracks in Sweden, over 100 years old, local train. And in that case, pretty simple way, I guess, of digitalization process. They just put basically a 360 camera in front of the train and then just drove the entire network and got a full view 360 picture of everything, which is then connected to the GIS reference and into the database. And with the not so super advanced AI, artificial intelligence tools, you can pick and select and extract the data on the tracks itself, on the overhead lines, on the installations, cabling, signaling systems, tracks, barrels as well. The problem, of course, you don't know what's behind the tracks. So that underground hidden structures are not visible and hardly can be easily digitized from the existing drawings or so. So it requires some time to get the full model. And then the last slide, something which mentioned at the beginning, we're working on those submarine structures. It's also, they are somehow hidden in the way, so not available, not accessible with the normal tools as we do. And with our company, Loxus, we're doing this underwater structure inspections and digitalization of them, let's say. And that's basically is done with the so-called ROVs, remotely operated vehicles, which basically is a submarine vehicle connected with the cable to the operator, so you don't have to send the divers. You can sit in your comfortable office and operate the ROV machine through the underwater structure. In our case, we're working a lot with the underwater tunnels or flooded tunnels in hydropower power plants or in the water supply systems, wastewater supply systems, and so on. And with that tool, we basically can get to the places where impossible to get. And with the collected data, we're basically able to generate the full 3D model of the tunnel, observe the eventual damages, eventual problem areas within this tunnel structure, and basically generating the centimeter precision detail 3D models of the submarine structures. In some cases, those centimeter precision maybe is not enough. Depending on what kind of sensor you're putting on the ROV, you can do the millimeter precision photogrammetry studies if you have enough good conditions, or even some submarine laser systems which can be used. So you can identify, depending on the task, what you want. You can get geometry, but you also can find the cracks in the concrete structures to be able to digitize. So on that note, we'll leave maybe some of the, not so many answers, but maybe some thoughts for our discussions late in the afternoon and pick from there. So happy to join these discussions later, and if you have any questions, it was a 2D presentation or slides, but if you want to see some of the models and how it's organized live, so please come by, and happy to show and share with me. Thank you.
Thank you, Andrius. We have a few specific questions, if you allow us. One is, I don't know, I'll try to interpret it by myself, but one of us is asking about common formats and open standards. And what do you think open IFC standard is liking to be used in the models?
Yeah, I'm not my IT expert or know about not much about that. I guess many people in the audience have better understanding of those format exchanges. But as a user, as a technical manager or designer, what I see the problem is that we have extremely good tools and advanced tools, commercially available tools that have to be own developed. But the issues which arise is basically that we can have a good exchange in the kind of visual coordinational point of view, different software models combined into one and visualize the objects we want to. But as I noticed that we losing a lot of the model intelligence which we build with the specific software, which basically either can't communicate with other softwares or can't communicate with the platforms which we're using. So I don't know solution and don't know the future. I guess people with the IT or the development have a better understanding, but from user point of view, I think one of the point was is that we have to find the common formats, both for the models, both for the model intelligence, and both for those kind of advanced models we're using and designing. So it's an issue.
Okay, thank you. Another question we have, what software do you use for soil modeling and BIM implementation? For soil.
Okay, I showed that model for basically geological models. That's for the rock engineering or engineering geology from the rock point of view. We're using it's a new emerged tool from 5-6 years ago, maybe a Leapfrog software, Australian developed software, quite commonly used in mining companies and now becoming even applications for the civil projects. I guess there's other ones similar or at the same complexity or same design, but we discovered that one was quite easy to use and very fulfilling requirements we needed. So in that case, I guess not important which kind of tool you use if you understand what it does and how it operates and that it can communicate with the other softwares. That's, I think, it's a big issue or the big question.
To understand is difficult, you know.
Yeah.
And the last question, more general, your ideas. How could we implement faster mass digitalization of residential buildings in order to speed up their renovation?
I showed only basically examples from what I work myself with the infrastructure project, but from the general understanding, I think the housing and the private sector of the construction sector, I think has a basic, maybe even better possibilities to succeed and succeed faster than compared to the large infrastructure projects. Then it's one client, maybe one construction, one factory, or one building, or one housing project, where you can basically isolate that project from the rest of your neighbors or rest of the infrastructure and just operate and build as a 3D project. But when it gets to the infrastructure projects, it's too complex. The time span for the decisions with the public clients are much longer, and regulations are long-lasting, and they're not so flexible and not so easy to change or affect. So I think for the housing projects, maybe it's easy in the way that you can start one housing project today, build it within 4 or 5 years, and have it as a fully digital model for the rest of the lifetime. So to digitalize existing building to the full-scale B model, I guess it's tricky. It can be done, but I guess it's costly and tricky. But at least the time span to reach the high degree of digitalization for one single process is shorter and faster compared to the infrastructure projects.
Okay, thank you for your answers. I hope we answered the audience.